Good afternoon, everyone, and welcome to the Power Lunch at Car MBS. This session is the Vehicle Electrification Drives Necessity for Cross-Discipline Systems Engineering. My name is Sam Abu Hamdan. I'm the head of North America operations for Aras Corporation. Aras, for those of you that are not familiar with the company, we are a software company that have a resilient low-code platform that allows you to data manage all your complex and products and processes. With me today is a panel of experts on the topic. So I will let them introduce themselves. I'll start with Denise Fitzgerald. She's with us on online virtually. Denise, would you please introduce yourself?
Hi, everyone. Can you all hear me? Yes, you can hear me?
We just need louder audio,
Sure.
please. Yeah.
I'm Denise Fitzgerald. I'm from MIT Lincoln Laboratory. Lincoln Laboratory is part of MIT. We're a federally funded research and development center, which means we develop new technology directly for the US government. We do this over a range of different areas, from radar to autonomous vehicles, actually, and laser communications, things like that. So lots of fun stuff. I'm a mechanical engineer by training, and I am now the lead of the newly created Digital Engineering Center at Lincoln as of Monday. So I'm happy to be here today, and I look forward to our discussions.
Thank you, Denise. And we also have Mike Varanczyk with us. Mike, could you please introduce yourself?
Yes, hello. My name is Mike Varanczyk. I'm the Chief Systems Engineer with the Strategy, Growth, and Innovation team at SAIC, Science Applications International Corporation, not the Chinese auto supplier who I believe is there. And so my team develops methods and approaches for our company to service our customers, typically federal agencies, NASA, DoD, other things, and enable them to facilitate their digital transformation, to steward their relevant content from concept through manufacturing and disposal of a given system. And so I tend to steward our validation rules and other technologies that we use to ensure the consistency and quality of our digital artifacts. So back to you.
Thank you, Mike. And also here with me on stage is Malcolm Pentecki. Malcolm, could you please introduce yourself?
Hi, everyone. I'm Malcolm Pentecki. I hope you're enjoying your lunch, and welcome to this session. I'm with Aras Corp. I'm VP of Analysis Solutions there. Arrived at Aras about 3 years ago through an acquisition in the simulation space, which is my background. And at Aras, I've been working on simulation, MBSE, and in charge of the general directions where Aras goes in these areas. Recently, I've begun working on our major OEM partnerships at the company. Welcome.
Great, thank you, everyone. As you guys have seen from the topic, or probably can guess from the topic, it's all about the electrification and how where the industry is going nowadays. You've seen in the news a lot of companies. You have Daimler that announced the other day with $47 billion that they're going to spend between now and 2030 on electrification. We've heard from Toyota that they're estimating also by 2030 that they'd have 70% of the entire U.S. sales in electrified or hybrid vehicles. Ford is investing a lot of money, so is GM. So there's a lot of interest, and we're going in that direction. So it behooves us to start discussing what it's going to take to enable that industry. What is going to take to start making sure that we address and talk about the challenges in that area, right? So we have a couple of questions that we have kind of prepared, and we thought this would be of interest to the group in here in this conference. The first topic that I want to talk about is kind of like the challenges that is facing the electrification, right? With focus on systems engineering, right? We know this automobile and that product that is so complex. It's a system of systems, right? And as you can imagine, with the producing a product like that, you have a lot of challenges. So my question is, first is going to be to you, Denise, is what are the particular and maybe new challenges, right, that we are facing when designing, producing, maintaining such a complex product like the electrified vehicle?
Right. So, I think the term digital transformation is kind of ironic because it's really about a transformation in the way that people work and people think about systems. You all know that technology is growing at an exponential rate, and it's transforming every industry, commerce, engineering, automotive, obviously, and thank you all, by the way, since my daughter is 16, for the continued commitment to safety in automobiles and strong armrests on my part from gripping. But when you think about what the result of all of this technology is, it's that we're able to create far more complex systems. They're not just hardware systems. We have to think about how all of these disciplines of people interact. And in the good old days, it was possible for all that information to be a human network, to have that understanding in people's heads, and our systems are driving to far more complexity that we can't do that anymore. So the shift in that paradigm of having that human-powered network to having that data-centric network where we can start to understand a system at a more fundamental level is important. But there's a real paradigm shift in how people think about that. And that shift from that network where it is so person dependent, the process in those systems becomes so important to people, and it becomes so process dependent. You really need to shift, and it really it affects critical thinking in an organization. And I'll give you an example in a moment. But in shifting from that person-centric network where you're so dependent on process to that data-centric network where you're so dependent on system thinking, on people understanding data and understanding the consequences of change in the system, that is the real paradigm shift and the real challenge in managing all of this complexity that we're adding, which is technically not that difficult. That comes with its own challenges, but having that paradigm shift in the way we think about design is really the challenge. So I think that is a major shift. And the example I want to give is we had a seemingly simple change we wanted to make, where we need to trace certification of parts. We do a lot of work for NASA, and we need to trace that the parts are good and not counterfeit. So we were doing that by putting a tag on a part number. And of course, that just kills the whole digital thread. So what we wanted to do was just add an attribute. And the result of that was the labels that were printed out from the stockroom were different. So this seemed like a simple change to me, and we asked the inspection group who manages that to if they bought into it, and it took them months, and they wrote out a massive test plan to show that it would still work, and we could show them the whole digital thread in the system, that they didn't need to depend on the label, and they came back and said, well, well, this is how we guarantee quality. And I said, well, did you ever think that your quality system is pretty poor if you're dependent on a label for quality? And they stopped when I said that. And they said, oh, we never really considered that. And we never considered that, there was a digital solution. So it's a paradigm shift of taking it out of the people, the process, adding the technology piece and using it as the center point to really change the thinking. So that's my broader answer to the problem at hand.
That's good. Thank you, Denise. Definitely the people challenge and the paradigm shift is a big one, and I will probably have a follow-up question to that later. By the way, I forgot to mention that we will try to keep the last 5 minutes of the session for questions from the floor. So we'll do that at the end as well. I want to, Mike, the same question to you. I know you're in a different industry than Denise, but similar, and just like it's always kind of nice to bring that perspective that's outside automotive, even, right? Although you guys with the DoD and the DOE projects that you do, you probably get into the combat vehicles and all of that, but your perspective is broader than that, and I'd like to see or hear what kind of challenges you guys are facing too. What's your experience like?
So, something very similar, and I will say automotive's near and dear to my heart. I spent 18 years at Ford, so I understand a lot about the industry, and I still am humbled by the fact that we make an incredibly complex consumer product, 60 jobs an hour, right? That has to die to protect you in a crash, get 1 million miles to the gallon, and be super comfortable to drive and everything. So I'm very proud of the auto industry, and so I tend to look at a lot of what I do in that context of that high volume thing. And if you think about it, cars today are emergent machines, right? The days of you can walk up and point to a box and know exactly what it does are gone, right? It's not obvious as we get more and more cyber physical systems in cars, and it's this coordination with the computers and other things. It really has increased the complexity, as Denise said. And because of that, as she indicated, the days of us being able to trust people, even competent people, to read a spec and sew it all together in their head are gone. The complexity is too high to manage with a person, no matter how good you are. And so there's this real need to get people to uncouple what they need to do from how they've always done it. And there's an enormous value. Again, my happy place is typically working on descriptive systems architectures, not executable. Even that alone will solve a ton of problems, where you can now communicate effectively with the FEA and other communities. Like, this is the system, here's how it behaves, and here's how I want you to go model. Because the high fidelity physics simulation of the wrong system doesn't give you any useful data, but you may not know that. So there's this real challenge to get people to willingly participate in this digital thread or tapestry or whatever term you want to use as we begin connecting data, getting rid of the air gaps, so that this updated mass number from Susie's CAD automatically feeds into Herb's FEA analysis. And oh, by the way, that means we're now blowing our drag calculations and we won't meet the range requirement or something. So to be able to detect errors and changes as quickly as possible is the huge benefit, as well as identifying gaps. And again, by expressing architectural information in terms of attributes and properties and relationships, we're better able to make safety cases. We could do failure analysis by leveraging our existing understanding of the system instead of a bunch of people going off in a room and trying to do an Excel-based FMEA. By sewing all this together, it really gives us deeper insight that allows us to answer tactical questions to our benefit, and the ability to put rules on it and other things to help us understand and analyze the system rather than try to parse human language, which I would argue is a fool's errand, but to be able to use an expert to structure the intent in a purpose-built language that's far easier for us to machine analyze. We can now detect gaps and inconsistencies and other things where you can now execute with speed, confidence, and rigor in a way you can't get to with a pile of documents. And by the way, I want to mention one other thing. I'm the treasurer of the International Council on Systems Engineering, and I'm pleased to report that our annual conference will be in Detroit next summer. And I really hope that we have a great showing from the auto industry to show all them folks that build them their satellites and aircraft that we know how to do good engineering in Detroit. So back to you guys.
Sure. Thank you very much, Mike. Yeah, in Cozy is a big part of Detroit and getting the systems engineering part of it. So yeah, thank you for that, Mike. Malcolm, from your perspective, being in product and software, what challenges do you see?
I've spent my career in software, but I really am an engineer at heart. I started that way as a structural engineer. I see software simply as a tool. It's a tool like any other. It's a very powerful tool. And when I look at this particular problem that this industry is facing right now, there are two major pieces to it. The people piece, and then of course the infrastructure and tools piece. You look at the people piece, the problems stretch all the way back to our education. We take engineers who think about wonderful, useful, sexy products and immediately put blinders on them. We train them in one particular aspect of that wonderful total system product. And then we bring them into industry and we put them into a corner and say, don't look at anything else because we need your expertise in this corner. That's a problem. Well, that problem isn't going to go away very soon because we're not going to turn narrowly expert engineers into systems engineers, but there's something we can do. And that goes back to the second part of the challenge, which is the tools and the processes. So think about that for a moment. Unfortunately, our tools and processes have also been siloed. And you make experts in tools in particular narrow aspects. So what can we do about that? That's not changing. We need that expertise again. So there's something else that's needed to tie all of this together from a people and tools perspective. And that's how we manage that data, how we expose the data to everyone who needs it at the right time, and how we ensure that people have access to thinking about the broader context of these products while they're working in narrow areas. And so you're not suppressing their natural innovative tendencies. Now, that's a bit of a tall order, but if we can tackle that well, we might be able to get the advantages of doing that without, in a sense, throwing the baby out with the bathwater. You need the expertise, you need the narrowness, but you also need a broader way of thinking. And I think that is the challenge we can face. And I can assure you from a software perspective, the technology exists to do just that.
Okay, thank you, Malcolm. Denise started out with the digital transformation, talking about kind of like the paradigm shift, and what Malcolm you're talking about, also tying to people to the technology. But digital transformation really is it means something different for different people. Right. We've been in this, Malcolm and I, for a while, and we were just talking to people. Everybody has their own kind of like definition of it. I want to go back to Mike for a second. And so in talking about digital transformation, how do you think that digital transformation supports that in initiative, the systems engineering, the systems of systems, and that systems thinking, right? And how would digital transformation really support that?
Well, I think it supports it by giving us the ability to get these really hard to answer cross-cutting questions answered with speed and fidelity and rigor. Because again, it's not a silver bullet, it's hard work. And my company's invested in some technologies to help us interchange data with a semantic broker. There's a whole ton of things we have to do, and it's really hard to make this work well. So I would tell anyone there, if someone comes in and tells you, oh, I can do a digital transformation for you, it's gonna be really easy, you should run, because they don't know what they're talking about. It is hard. I tell my students, I call it shoveling the coal. There's a time where it's really hard work, but the payoff is that we can catch errors and mistakes and gaffes as early as possible. Now, if it's a software system, it could be something like, we've set up a system and we discover by analysis very quickly that no one is sending the command that turns on the solar panels or deploys them or something. Well, that's the sort of thing that may leak all the way through to test integration traditionally. So we have this ability to catch mistakes as soon as they're made. which again allows us to increase the tempo of development. I'm sure none of you are facing any pressure from your competitors. So you have all the time in the world that you want to do the work, right? And so, I'm being a little facetious, but I really feel that companies that do this and do this well are going to get a sustainable competitive advantage because it is so hard, but it's also, I think, table stakes for survival. And so this ability to sow the knowledge we have about the design intent of our system, and that's really what I think good systems engineering does when in an architecture. It helps us understand the design intent. So the detailed expert who's the world's greatest expert on spark plugs or fuel injectors knows what they have to do, right? We're able to craft this system of systems with all this fiendish complexity of software, and electrification's upending things, right? When I started in automotive in 1990, it was obvious. The engine made torque, the transmission got it to the wheels, the body carries you around, the brakes stop you. Well, now you've got regenerative braking. I mean, there's so many things where functions are moving around or becoming an emergent behavior of multiple systems that typically didn't interact a lot with each other before. It really is important for us to really know what we're doing, not to just think we know what we're doing. Because as I tell my students all the time, the most dangerous person in the world is someone who thinks they know what they're doing. And a competently executed digital transformation gives us the ability to really know what we're doing, right? That we can express things in clear terms, sew the information together. When I teach my students, I tell them if the model's right and the query's right, the answer is right. And it often can expose things that would be very difficult to track down manually, as Denise said. This network of people and the ability to sew it all together in your head just breaks down. There's analyses that would take weeks of doing, combing through multiple specs that we could do in a matter of seconds with a competently executed query. And that's the sort of thing I think we have to do to make sure that we have this well-crafted design intent that gives us the ability to succeed with a detailed design. I mean, you can still mess that up, but at least we made sure the intent was right from the start and it was safe, effective, and did all the other things we needed to do. So back to you guys.
Very good. Very good. Thank you. Denise, at MIT Lincoln Lab, I'm sure you have different flavors of digital transformation, and you probably have maybe multiple platforms even, right? So how do you tie the two together, right? The platform to the systems engineering, and how do you have a very good way of enabling that systems thinking?
Sure. So, yeah, as comment on what Mike and Malcolm said, I was thinking in terms of this conference and transportation as a whole, and this digital transformation is similar. And I'll give you my analogy is that when the automobile came into practice, our network of what we could reach grew significantly. Our world that was very insulated suddenly expanded. We could go places. We didn't necessarily live near our families or the town we were born as a whole. I'm not that old, but over time, the world has expanded due to transportation. So data is no different, right? So in the past, we've been in these little silos within our discipline, within mechanical engineering or software. And now, as we're thinking more system level of how all of this connects through behaviors or architecture, we're starting to expand that thinking where it's moving outside of that little neighborhood of your discipline. And the platform becomes really, really critical in a way that you can bring all of that. It's the roads, it's the roads that connect us all. So we can bring all of these different pieces of data and information together and then consume them in a way that's meaningful. So for us, where we have very disconnected systems. We have the software guys do their thing in one system. We have the mechanical people have their own system. We've recently had some issues where the wrong software was used on a mechanical system and our electronic system, and we need to tie that together and find those issues, stop them. So the platform becomes critical. Of course, we're using Innovator as the platform. But there are other solutions as well. But understanding the relationships, again, how people work, how their data connects to each other, how we can use it, break down the silos, allow that world to expand, and that understanding of the entire system to expand. And that's what leads to that system thinking.
Thank you, Denise. Malcolm, so you've been in systems engineering for a long time too, and you've again, you worked with software and different platforms. How do you see that coming together?
So when we think about digital transformation, we often start out thinking about the data, putting the information together in a coherent manner, linking it up together so you can access the information when you need it. That's part of the equation. Accessing the information is vital, and it's table stakes, I think. The next step is allowing people, anyone, engineers, the business community, everyone involved with the process of creating these amazing products to be able to do something with the data. So it's get the data right first, but then be able to put the tools in the hands of the people. Now, here we run across the silo problem again, where you've siloed the tools, the certain people only can use particular tools. And so the next important step, besides getting that data layer right, is automation. The experts being able to automate the processes they normally go through so that you can now put those automated, packaged capabilities in the hands of anybody who wants to ask the right questions and to get accurate results back. So back to the question about digital transformation, broadly speaking, two pieces: taking the data and getting it right, and that's a very company by company process, so you need a flexible data modeling environment to do that, and then the ability to automate processes so that anybody who wishes to ask the right questions can get the answers. So it's two-pronged, and these two need different approaches and are just as difficult.
Staying with you, Malcolm. So let's talk about the digital transformation initiatives. So you and I have seen also different clients that we have had, how much money they spent on digital transformation initiatives, right? And we came across a number in here that it says 50 to 70% of digital transformation initiatives fail, right? So from what you have seen from different clients and different implementations of digital transformation, what, in your opinion, are some of the pitfalls that we could avoid?
So that sounds like a pretty scary number, right? 50 or 70% of these very expensive enterprise-wide initiatives failing. And there's a good amount of truth in that. It all depends upon how you define digital transformation and how you define failure. But the fact that there have been a lot of failures has been obvious, with lots of money poured behind it. So what are some of the main reasons why this has happened? Not in any particular order. Not coming up with good goals, well-defined goals, has been an issue. Not getting enough support at the highest levels within the company, another problem. And that support, I don't mean lip service and putting something into a memo, but real resources behind it. Taking old and existing ways of doing things and tools and expecting that you can just simply, quote unquote, digitally transform them and expect them to work well, another problem. Taking people who've been used to working in a very siloed environment and then expecting that they're suddenly going to think more broadly, it's not going to happen. And not putting the right people or persons in charge of such initiatives and making sure that they have all the tools and the authority. And then finally, wanting to boil the ocean. Let's digitally transform the company, and in a year and a half, we're done. Ain't going to happen. Start small, get the successes that you need to get from those, learn what works and what doesn't, expand from there and keep going.
Thanks, Malcolm. Mike, at SAIC, I'm sure you have done. I mean, it's a vast company, and a lot of people also work on different projects. I'm sure you have a couple of digital transformation type initiatives. From your experience, also, what are some of the pitfalls, things to avoid? What would you be able? What's your comment on that?
Sure. So first of all, I echo a lot what Malcolm says, and actually I would point everyone who's interested in this. There's a great paper from a competitor, Ryan Noguchi at Aerospace, talking on lessons learned from model-based systems engineering projects. And I would argue that's a freely distributed report, and it has a lot of things equally applicable to a digital transformation. I think the first mistake you make, as Malcolm said, too big a scope, right? Big projects fail, small projects succeed. So break it up into small, eat the elephant one bite at a time. Find your greatest pain points and begin tackling those while keeping an eye towards the end state that you want. So make incremental value added steps and find ways to add value every step of the way. One of the things that I always believe in is you have to show the wow. And so when I get involved with a project, you have me model and you get results immediately, not like, let me go off in the corner and model and like 6 months from now, I'll show you something maybe. So there has to be this constant demonstration of value add. That does two things. It gets people engaged and they want to participate because they see the benefits. And it also gives you momentum, right? So then as you start to build up successes, people see that this isn't just flavor of the month. They can't just hunker down and outlast it, that it is truly transformative and they're getting value. So as an example, one of the first projects I worked, the safety person began engaging with the architecture, and we brought the safety database in, and then it was in sync with the architecture. And then we had some rules that if you were an input or an output to a function that led to a catastrophe, you were safety critical. So we started working that. And then we had someone say, well, gee, this thing should be safety critical. Well, not according to our rules. So either you're wrong or we're missing a connection. And so people rapidly began to weave this connective tissue where the specialty engineering and everyone else began to benefit immediately as decisions were made and things began to cascade. Now, the other thing you have to focus on is the people. So I'm assuming you're going to invest in the right tools. My advice to anybody doing this too is hire the smartest, borderline arrogant, competent person you can find. And the reason I say that is this is not going to be done by a shrinking violet. It's difficult, hard work, and you've got to have someone with just enough swagger and confidence to pull it off. And so it's not going to be done by a committee. You need the really competent, capable person that can kingpin this and make it happen, and have the drive and the authority to make it stick. And again, they have to be able to deliver on the value. You can't hire a charlatan or a quack. And so that's the challenge right now is there's relatively few people that are capable, qualified, and have the right personality to make this happen. The final piece of advice I would give is don't try to retrain everybody to be a digital engineer, architect, systems engineer, MBSE person. It takes a certain mindset. You can't just anoint someone with the holy oil and poof, they're magically going to do it. It takes a certain personality type, a certain broad-ranging interest, the ability to see things as a system, the outgoing nature to interact with the domain engineers. And so for the foreseeable future, I think the path to success is to get a small, competent team of qualified, capable people where this is their happy place. They like seeing things in terms of systems. They like using the tools, and they can be the bridge between the emerging tool chain and the people that need to consume the data. Every time I see someone try to train everybody on how to model in SysML or how to use the new tools, it just fails because you've layered extra work on people on top of their day job, using something they don't like to think this way anyway. It's a recipe for failure, as opposed to, hey, Susie or Bob is the digital person. They like doing it. I engage with them. I own the content. They own getting it into the system. We work together as a team, and look at the benefits I'm getting. So I really think for the short term or medium term, at least, you're going to need this cadre of people to really make it happen. You're not going to succeed if you just magically try to train everybody in the organization and expect it to work. You need the I hate to use the term high priests or shamans, but you need the people that are going to interact with this to really drive the success, because they understand how to squeeze all the value out of the system and the domain engineers know what they need. And by building a fruitful partnership with these different skill sets, you're going to get really a rapid success that'll be the envy of your competitors.
Thanks, Mike. Denise, same question. I'm sure you have a lot of smart, capable, confident. What was the other one? Arrogant, also, Mike.
Borderline arrogant.
Yeah, MIT Lincoln Lab. What anything you have to add?
Sure. So, I like to think about transformation. Your organization is a system like any other system. You need to apply systems thinking to your transformation. So, or you should, not to be too arrogant, but, you should think about it at different levels. So there's the strategic level. It's very important to me to have a vision. And I constantly ask people in the leadership positions in my organization, where are we going? What should we be? What does Lincoln Laboratory look like in 10 years and 15 years and 30 years? What does an engineer do when they come to work, or go in their living room and go to work, as we have been? So, that, and understand that vision is not static. That needs to evolve constantly as your understanding and your transformation evolves. Then you need to think tactically. So, have a framework for how you transform. And the number one thing, I think Malcolm said it, is ask yourself the question, what problem am I trying to solve? If you start with what you do today, you've lost already. Start with, what problem am I trying to solve? What solution could I bring in? And does it match my vision? That's the most important step forward, because if you can't answer that question, or those couple of questions, you've already gone in the wrong direction. And you will spend more time trying to force that solution that you're putting in place into your long-term plans. And I think that's a lot of times why a transformation fails. So then, we have a framework that we move through, and there are certain things we think about as we move through the transformation process. What old processes are we impacting with the new ones, or new technologies, or new ways that people need to work? What does that mean for the organization as a whole? Not technology is easy to bring in, but again, that transformation of how we work. Did I think as much about the methodology of using these new tools? And that could be MBS. It could even be a new way of thinking about CAD. It could be anything. But did I really think about how to use it? And then finally, there's the operational level. How are the people going to adopt this? Do I have the right change plan in place? Have I thought about training? Have I gotten champions lined up? And have I gotten some buy-in and some people involved early on, so that they can bring the goodness and the excitement out to the rest of the community? That's probably grumbling about it. So, all of those things, it's a top-down look at transformation. And I feel I've seen plenty of examples where solving a point problem caused a rippling effect throughout the organization, and throughout silos and people and methodologies, and it never works particularly well. So I would just, same as the system design, top down, maybe a little bit of experimentation, bottom up, but really build it into the fabric of where you want to go, and measure that. Measure, are we moving in the direction that we thought? You might answer no, but we're moving in a better direction. Change the vision. That's allowed.
I would say one comment with Denise about the experimentation. I think she's spot on, because every time I see someone try to go off in a conference room and plan this out to 9 decimal places, it fails. And so I would argue you need enough backbone to not be a jellyfish, but you also want to abstract from success. And so I think there's this real need to do both, right? Because again, your company is unique. It's got its own culture, its own needs. And the other thing I was saying about what Denise was saying was that as we automate and transform, we don't necessarily do exactly the same products as before. If you're a blacksmith making a tent stake, you draw out a piece of iron to a point, you bend it into a 7 shape, pound it in, you're done. When we automated tent stakes, they don't look like that anymore, right? They're injection molded, or it's a piece of wire bent or something. So you get equivalent function and outcome, but not exact. We didn't automate exactly what's there. And I think a lot of problems, too many organizations have these huge old bloated processes that existed because of the limitations of paper-based and document-based and human network-based engineering. And I would argue, and the change control police hate me, but I really believe a lot of those change control processes we don't need in the same way, because the competent digital engineering, we make a change, we can immediately identify who's impacted, we can get all the right people in and talk about it, and you could probably lightweight your change control process enormously compared to what you've been doing, because of the ability to be more focused in who needs to approve and understand in that. So again, think about that also. You're not just here to transform what you were doing, in an analog effective way into digital, but to think through of, what are the implications so you can get the benefits. Because if you just automate exactly what you're doing today, you're going to just institutionalize drag and not reap the full benefits. So back to you guys.
That's a good point, Mike. I'm reminded early on. I mean, talking about the kind of like not doing things the same old way. I early on I worked with a major OEM, automotive OEM in the 90s, where we tried to kind of help them out with some projects, and we found out that engineers touch about 22 systems a day in order to go and find data, and that's how the system was designed. And so today we talk about the concept of digital thread, right? How you can build that digital thread that goes through the different data silos that you have. So Malcolm, I want to talk about the digital thread a little bit, because I think it's very important in today's world, right? We have a lot of legacy data, we have a lot of systems. We don't want to do things the same old way. How important is the digital thread in today's world, and how we design these systems?
Sam neglected to mention that those who left early are missing out on that very special gift that's under each of your dinner plates. Now that I have your attention, let's shift to digital thread. Digital thread, well, that's another buzzword that's been showing up over the last few years, I'd say. Just simply speaking, you're looking at a platform that holds a certain amount of your data, whatever that might be, everything associated with your product in this case, and thread as in connected. So it's more a fabric, really. It isn't a single thread. That's a bit of a misnomer. So you've heard other terms like digital tapestry in the past as well. But the bottom line is the connections between the data. These data have existed in some form, in some silos with some tools for quite a while. Now it's a matter of extracting key pieces of information. You're not extracting everything. Key pieces of information that then, through relationships with other pieces of data, make 1 + 1 = 5. Because it's those powerful, rich relationships that really allow you to query the information better, ask the right questions and get the right answers, and also be able to infer things that you otherwise couldn't because you had a very siloed view of information. So a couple of things that I said that's important with this digital thread: the extraction of information out of the much more detailed pools of data that exist with these detailed tools. So you're pulling out certain key pieces, and each company decides what that is. And that's actually a key differentiator. And then secondly, once you get the information from each of the silos, then being able to connect them together to form very rich relationships using these graphs of data. And then that gives you traceability over time. That allows you to manage versions over time. It allows you to do configuration management, which is key as you look at electrification in particular. It allows you to be able to ask questions, not just about the design, but about manufacturing, about individual instances of the products in the field. And it's all connected. And that ultimately allows you to create the infrastructure that's required to really encourage systems thinking amongst all of your engineers who are capable of doing that.
Thanks, Malcolm. Denise, digital thread at MIT Lincoln Lab. I mean, have you been able to utilize that to your benefit in tying any data silos? And if so, how were you able to achieve that?
Yeah, I mean, digital thread is the central concept of all of this, and using the platform to do that is critical. You know, if you think about it, the way engineering is going as a whole, and everything digital is transformation. It's about modeling and simulation. It's about having some digital representation of something that's a model, and being able to use that digital representation to show real behavior. The models don't really talk to each other, though. You know, they're written in different languages, so you need that digital thread to connect to some common Rosetta Stone. It could be parameters that what Malcolm talked about. It could be items in a system, some other digital representation that allows you to connect them together. But it really that we flow all of our data through the platform to create that digital thread, and that's critical. So we're in the process right now of connecting our systems engineering models and pulling some of those parameters out, especially in requirements, so that we can do V&V on the platform, of tying the simulation data, so that we can understand, what we actually, tested in the virtual space of our hardware designs, and both electronic and mechanical. As software is coming, that's a little bit further out. But then, when we actually do build and test, tying those results back to the original system, and even the execution of that, of those builds, how we do it, putting the remodeling procedures so that we can tie the data directly back. So that, digital thread is, that's how we get the value out of the system, and how people can understand all of this massive data that we've opened them up to. And I will add one other thing. The 22 systems that the engineers have to access. I actually did a study about this, and our engineers didn't do that. They actually went and asked people, and it took them 3 days to get an answer, because they might have been a little bit down in the queue of the people, as far as importance and actually answering those questions. And a lot of times the answers were wrong. So, and then they took that and they put it in a spreadsheet. So we said it's 3 days to get an answer. It was an enormous number of people to get the answers. So again, that human network, access information versus trying to be a detective is really important. So single source in which to look for the truth. The truth might be coming from different places, but
sure,
one source to access it.
That's a very good point. I know we're coming to almost to the end of the session, and I want to make sure that we leave enough time for questions from the floor. Any questions? Anyone?
Thank you. Thank you very much for the session today. It's been very informative. I'm Graham Cousins from Quantum Corporation. Malcolm, can you address specific challenges that companies are facing when it comes to outdated legacy IT infrastructure that is unable to support the type of data sharing, data mobility that you're referencing? And I'm talking about not software, but hardware specifically.
Interesting that you bring up hardware rather than the software. That certainly has to be the appropriate background infrastructure upon which you then layer the appropriate software. And in our distributed world today, the move to the cloud is pretty important. And I think that you have to be able to share ubiquitous hardware with access from anywhere, on which you've put the appropriate software and software layers that then make the data and the tools and the processes also available ubiquitously and from anywhere and from ultimately almost any device. So those are infrastructural pieces that often need to be in place as you move forward with this digital transformation process. However, word of caution, as all of us have said, boiling the ocean or wanting to boil the ocean before you do anything else is a pitfall. So rather than worry about outdated infrastructure, you start small. Choose a smaller project for which your current infrastructure works just fine, and then build on top of that.
Thanks. Thank you for the question. And any other? Oh,
Mike wanted to pitch.
sorry, Mike, you will have follow-up? All right, something to add?
Well, I was just going to say one thing. I don't want to sound too cavalier about this, but if it's a problem that only takes money to solve, it's not really a problem. Now, now that doesn't mean you want to bankrupt your company, but again, if there really is truly a hardware issue, there's ways to solve that. It involves opening up the checkbook. So just make sure you end up buying the right thing. But if you're going to try to transform the company, don't cheap out on people and don't cheap out on the equipment. Because again, if you're going to do this, the last thing you want to do is pour, you spend half what you should have, and then you get zero for it, right? So again, don't be afraid to commit sufficient resources, because if you don't, it's not going to work out. Now, that doesn't mean you can buy your way to success, but don't set yourself up for failure either.
Good. Denise, do you have anything to add?
No, I've enjoyed taking part virtually. Hopefully we can.
Okay.
Although you're all meeting together, but I was going to say hopefully in the near future, travel at least for my space will open up a little bit more.
For sure. Thank you. Any other questions from the floor?
Hey, this is Karthik. So I do come from an engineering services background, and I'm sure there are many tier one suppliers and everything. So if an OEM goes for a particular systems engineering or company level or organization level, some kind of digital thread or digital transformation, how can they then, so because a tier one supplier or engineering services have to deal with different OEMs and different organizations, how can that be managed between the org? Because let's say for Ford, a Ford can afford to have one particular way of working, and so will have GM, so will Stellantis. How does a tier one supplier or engineering services provider connect with each one of them and still be a part of the mainframe?
Is that a question to a particular panelist?
Anyone can answer.
Anyone?
Yeah.
Who would like to take that on?
I guess I'll throw one thing out there, because again, at SAIC, we have to interact with multiple government bodies. Some use my favorite tools, some don't, right? And I would argue this. Number one, there's technologies like, again, we've got the semantic broker. There's other ways to exchange data between tools. So, but by definition, the minute you add an interface, you're adding an energy cost to create and maintain it and synchronize across it. So that's not optimal, right? A perfect world, everybody would use the same tool. They're not going to. I would argue you're going to need experts in each, right? Like I flat out refuse to work with certain tools because I need to be the best expert I can be with the tool I do use. And we have somebody else who's the best expert at something else. So you're going to have to, I don't want to say set up centers of excellence, but you're definitely have to have teams that are proficient with the various tool chains for your customer base. Now, internally, I would encourage you to find tools that play nice with each other to do your work. Like Aras does, in my opinion, again, this is not me speaking for the company, but they do a pretty good job of allowing data to exchange between, disparate CAD systems, other things, PLM. It's important to have a trusted partner that you can work with that can handle that interchange, because you don't want there to be friction. It's going to detract from your performance. So yeah, there's no way for you to hold a gun to Ford, GM, and Chrysler or Stellantis' head and say you guys all have to use NX or Creo or whatever. You've got to find ways to not impede your internal workings. And again, some of this isn't important, right? You may have a part for Stellantis that's never going to go in a Ford, so it's okay that they're segregated, but there could be a common component that works across them. And that's where the challenge is going to be, to build your thread robustly so that it can easily interchange data with whatever the OEM intends to levy on you. And so that's my advice. Find a trusted partner to handle that abstraction or that interface layer so you don't suck resources from your efforts to make that work. As a tool person and a practitioner, I expect the IT infrastructure to work. That's somebody else's problem. And when it doesn't work, it keeps me from doing my job and the meter's running. So I encourage you, work really hard to find the right partner to handle that for you. So I'll turn off the class 3 rant. Back to you guys.
You know, I'd encourage you to imagine the following scenario where you, as a, let's say, a tier 1 or tier 2, have to deal with these different systems from the different OEMs that you provide services to. However, you face the problem internally of these various systems. Imagine now a system that behaves more like a federation tool, a single system that your people master, know well, and you're able to connect and map to the various systems that the different OEMs dictate that you work with. And if that's possible technologically, then that's probably the best case scenario for you.
Thank you, Malcolm. Denise, anything else?
I would say, and this is not the satisfying answer, but you know, interoperability is a huge problem industry-wide. And if I draw the analogy to CAD, it's gotten better. It's not perfect. A lot of CAD systems can interoperate natively at this point. It's taken a lot of years to get there. The standards are not, STEP, for example, are not perfect for data exchange. MBSE has to mature to that level, and the unsatisfying answer is get involved with those standards committees, INCOSA, NIST. You know, there are a lot of groups out there. The more we all, as practitioners and users of these tools and organizations that do carry quite a bit of leverage, we have to make it known to the manufacturers of these tools that it's important to us. And until we can do that, I agree with what Malcolm is saying. You know, think about federation and different techniques to do that connection.
Yeah, and to leverage on that, I agree with the federation concept, because integration is dangerous, right? I think federation is the better choice, because that way you can pick your best in breed tool here, here, and here, and then tie them together. Of course, you'll always get better performance if you buy the vendor end-to-end solution, but almost nobody wants to do that. And so I would encourage you, as a community of users, Denise is exactly right. First of all, we have to work on the standards. Like the SysML 2.0 standard is going to force more interoperability between tools, but we have to hold the tool vendors accountable that, hey, we are not going to write you a big fat check so you can vendor lock us, because your PLM solution isn't very awesome, but I'm stuck using it because it plays nicer with your CAD, right? We should be holding these people to a higher standard in terms of, we own the data and we should be allowed to assemble from Legos what we think is the right solution for our company. And they're going to hate that, but at the end of the day, you're writing them the check. And so you should use that power to some extent to thoughtfully encourage these tool vendors. I mean, yeah, there always are going to be advantages to an integrated set of tools, but I think we, as a community, we really have to enable that interoperability and hold them to account for functionality, to ensure that the tools do what we need. You know, maybe if they would spend less time gold plating certain, you know, features that nobody's really asking for. And again, I'm not trying to say squelch innovation, but I think that we should be pushing back for more table stakes for data interoperability. That would streamline the digital transformation enormously. So back to you guys.
Thank you very much. We're coming close to the bottom of the hour. On behalf of Aras Corporation, I want to thank the panelists. This has been a great discussion. Thank you all. I want to thank CAR MBS for putting this beautiful conference together. I hope you guys have found a lot of benefits out of this session and all the sessions here at CAR MBS. And thank you for your time. Enjoy the conference.